So gravitational potential energy at infinity it is 0, that we have already seen, and gravitational potential energy at any point at a distance r from the center of the earth is negative. So that point also we have already seen. And what is the formula for finding potential energy, gravitational potential energy? That is minus gmm by r. While what is the gravitational potential? It is minus gm by r. Now what will be the potential energy at surface of the earth? If we are considering a mass of small m which is at the surface of the earth, then what will be the potential energy of the system? We have to consider that there are only two masses, that is the earth and the small mass which we have taken. So it is minus g capital M small m by r. And if we are interested in finding gravitational potential energy at height r by 2 from the surface of the earth, then what will be the gravitational potential energy? So let us find it. So please see, so if this is the earth, and if suppose this is the mass which small m we are considering, and we are considering this at height r by 2, so this is where our mass is located. So this distance, so we have to consider this total distance. So what will be this distance? That is r by 2, they have given in the question, and this distance is r. So generally gravitational potential energy is minus gmm by small r. So minus gmm, what is the small r here? That is the total distance. So r plus r by 2. So that is minus gmm by 3r by 2. So it is minus 2 gmm by 3r. So that is the answer. So now there is another question. What is the work done in lifting an object from the surface of the earth to height h is equals to r by 2? So it is when mass m is located at the surface of the earth, and we are taking that mass to a height r by 2 from the surface of the earth. So they are asking what is the work done. So work done is nothing but a change in potential energy. Okay, and initially what was the height? So initially height was 0, but what we have to take for potential energy, we have to consider the distance from center of the earth. Okay, so that we should not forget. And h2, what is the h2? That is r by 2. So next it is taken to the height h r by 2. Now work done is nothing but potential energy final minus potential energy initial, because here we are dealing with potential energy only. So what is the final potential energy? So this is the final case, minus gmm by, what is the distance we have to take? From the center of the earth we have to take. So that is r plus r by 2, that we are taking. Minus, what is the potential energy initial? Minus, this minus is here, and potential energy initial, again this minus capital G small capital G m small m by r. Why we are taking only r? Because initially it was at the surface, so the distance between it and the center will be r, radius of earth only. So now, so this minus and this minus and minus become plus, so it is plus gmm by r. So if we are adding these two, we will get the answer. And here we are just seeing a formula, that is we can use it like this also. Potential energy final minus potential energy initial is equals to gmm into 1 by r1 minus 1 by r2. So why we are writing like this? Because so this is minus, again this is minus of minus, so this will be plus. So generally it will become like potential energy initial minus final, and if we are taking minus as out, then it will be gmm into 1 by r1 minus 1 by r2. Now let us see an important topic related to escape velocity. So first we are going to see three cases. Okay, from the surface of the earth we are going to project a body. First case with the velocity that is equals to the escape velocity. So in the second case we are going to throw it with the velocity less than the escape velocity, and in the third case we are going to use the velocity which is greater than escape velocity. And let us see what happens in these three cases, and let us see if the required formulas. Okay, so first we are projecting the body with the velocity, that is escape velocity only. So initially it is at the surface of the earth, that means it should have a potential energy. Okay, and we are projecting with it with some velocity, so definitely there will be kinetic energy, and it is going and it is reaching the infinity. If we know already at infinity the gravitational potential energy is 0, so u will be 0. And if we are projecting with escape velocity, then at the infinity its velocity will be 0. Okay, that point we have to remember. If we are projecting an object with escape velocity, then at the infinity its velocity will become 0, that is its final velocity is becoming 0. So what is the final kinetic energy? So that is also 0. So this is the first case. Now let us see, for the case we are projecting the body with the velocity less than the escape velocity. So I have already mentioned a body thrown with a speed x into ve from the earth surface. So it is something multiplied by x. Okay, ve into x. So if x is lesser than ve, what x is lesser than 1, what does it mean? So it may be 0.5 ve. What is 0.5 ve meaning? Ve by 2, that is definitely lesser than ve only. So if x is lesser than 1, if this is the case, if x is lesser than 1, that is the projecting velocity is lesser than the escape velocity, then what will happen? So we are projecting at like this with the velocity xve, and here x is lesser than 1. Okay, now initially what are the energies it was having? Initially there will be definitely a potential energy, and we are projecting with some velocity, so there will be a kinetic energy also. But what is going to happen is, as we are projecting with a velocity lesser than the escape velocity, it will not be reaching the infinity. Okay, why it will not reach infinity? Because there is no escape velocity given. Say velocity lesser than that was given, so it will not reach infinity. So before infinity it will reach somewhere here, and it will stop and it will come down. Okay, it is like at the maximum height its velocity will be 0, only then it will start falling down. So final velocity is 0, so the kinetic energy at that point is 0. Now what is the potential energy? Will it have any potential energy? Yes, it will have. Why? Because here it is not infinity, it is not at all reaching infinity, so there will be a value of potential energy. So if this is the height reached, at that maximum height there will be only potential energy and there will not be any kinetic energy. Now the general question asked is, what is the maximum height reached if the velocity is something xve? Then the simplified formula is rx square by 1 minus x square. What is ix here? We have to take this x. Okay, if suppose that is 0.5, please take that is 0.5 only. If it is something lesser than 1, for example 3 by 5, if that is the case, 3 by 5 ve, then we have to take 3 by 5 as the x. Okay, then we can get what is the maximum height reached. So I have given an example also. If v equals to ve by 2, then h will be r by 3. So you can substitute 1 by 2 in this formula and you can get this. Okay, you please try to get this one. And here I have shown law of conservation of energy. Let me explain that one also. So initially at the surface of the earth, what is the total energy? That is potential energy plus kinetic energy. So that the potential energy is nothing but minus gmm by r. What is the kinetic energy? Half mv square. This v is nothing but this one. Okay, this xve. That is equals to, what is the final energy? There was no kinetic energy, only potential energy. So it is minus gmm by r plus h. So this is the h. Okay, so this is way we are going to use the law of conservation of energy, and from the law of conservation of energy only we have arrived at the simplest formula. And it is good to remember this formula because it will be useful in many cases, as it will not be time consuming. Now let us see the third case, that is if x is greater than 1. If x is greater than 1, it means it is like 2ve or 3ve, it is like that. Then v will be greater than ve, that is the velocity with which we are projecting is greater than the escape velocity. So then what will happen? We should know that. So initial we are projecting with a velocity greater than escape velocity. So definitely velocity more than escape velocity is given, so it will be definitely reaching the infinity. But after going to infinity immediately, the velocity will not be zero because we have given much larger velocity, so its final velocity will not be immediately becoming zero. So we should not take final velocity as zero. Okay, so kinetic energy will not be zero. If velocity has some value, then kinetic energy has some value, but it is reaching infinity. So at infinity, gravitational potential energy is zero, so u equals to zero. Now here the general question asked is, what is the velocity, what is the final velocity after it is going to the infinity? So that is the general question it is asked. So v infinity equals to v into under root x square minus 1. So this is the general formula which we have to remember, so that it will be helpful to find the final velocity just after reaching the infinity. So what is the x we have to take? So if it is 2 times ve, then the x you have to take is 2. Okay, 2 square minus 1, like that. I have shown it here. If v equals to root 2 ve, then v at infinity will be equals to ve into what is root 2, that is x square, that is root 2 whole square minus 1. So root 2 whole square means it is 2 square minus 1. So that is sorry, root 2 square minus 1 is 2 minus 1. So that is 1 into ve, so that is ve only. So similarly, if you want, you can apply some other value and check the value of velocity.